Let's talk about angles. We all know them, we all use degrees, but have you ever really stopped and asked yourself why? Turns out there's a much more natural way to talk about circles, a language that the circle speaks itself. And today, we are going to demystify that language, the language of the radian.
So, let's just dive right in with a big question. Why on earth are there 360 degrees in a circle? I mean, we use it for everything from navigation to pizza slices, but where did that number even come from? Was it handed down from the heavens? Well, the truth is a little more human. You see, the whole 360-degree thing isn't some fundamental law of mathematics. Nope. It's basically a very, very old habit that we picked up from the ancient Babylonians, like over 2,000 years ago. They had a number system based on 60, and 360 was just a super convenient number for them to work with because you can divide it by so many other numbers. And this is the main point right here. 360 was chosen because it was convenient, not because it was mathematically necessary. It's a completely human invention. It works, for sure, but it has absolutely nothing to do with the actual pure geometry of a circle. It's just a tradition we never really questioned. So that begs the question, doesn't it? If 360 is just an arbitrary number someone picked ages ago, could we have picked something else? And the answer is, yeah, absolutely. In fact, people have. Just as a quick example, there's another unit out there called the radian. It was developed around the same time as the metric system, and it chops a circle up into 400 parts instead of 360. It just goes to show you, the number we use is totally a matter of convention. It's just an agreement. Okay, so this gets you thinking, right? Can we get away from these man-made numbers? Is there a way to measure an angle using a unit that comes, well, from the circle itself? A truly natural unit that any intelligent life form in the universe could discover on their own?
And the answer is a huge, resounding yes. And that, my friends, brings us to the hero of our story today, the radian. A radian isn't just some number we picked out of a hat. It's a unit of measurement that is born directly from the circle's own properties. So here's the core idea, and it's actually beautiful in its simplicity. You've got an angle at the center of a circle, right? That angle creates a little curved section on the edge. We call that an arc. 1 radian is the exact angle you need so that the length of that arc on the edge is exactly the same as the length of the circle's radius. It's a perfect one-to-one relationship. The best way to picture this is to imagine you could literally pick up the radius of the circle, like it was a piece of string. Now, if you take that string and you wrap it along the outer edge of the circle, the angle that it creates back at the center, that is 1 radian. It's elegant, it's simple, and it comes from the circle itself. No arbitrary numbers needed. Okay, cool. So that's 1 radian. But what about the whole circle? If we kept taking that radius-sized piece of string and laying it down end to end all the way around the edge, how many times would it fit before we got back to where we started? Well, to answer that, we just need to dust off a formula that we all probably learned in middle school. The circumference of a circle is 2 times pi times the radius. C equals 2 pi r. The answer has been hiding in plain sight this whole time. And there it is, boom. The formula literally tells us how many radii, that's the r, fit around the circumference. It's 2 pi, about 6.28. So a little more than 6 of those radius strings fit perfectly around the edge. And since 1 radius wrapped on the edge equals 1 radian, a full circle must be exactly 2 pi radians. So now we've got these 2 different ways of describing one full turn. We have the old school, arbitrary way with degrees, and this new, totally natural way with radians. So let's finally connect the dots.
And this right here, this is the big aha moment. They are just 2 different names for the exact same thing. 1 full rotation is 360 degrees, and it is also 2 pi radians. They are equal. They describe the same physical action. This is the one thing you need to burn into your memory. 360 degrees equals 2 pi radians. We can even make it a bit simpler by just dividing both sides by 2, which gives us the even handier version, 180 degrees equals pi radians. Think of this as our Rosetta Stone, the key that lets us translate between these 2 languages.
Okay, so we've got our Rosetta Stone. Now let's get down to brass tacks. How do we actually do the translation? How do we convert from one unit to the other? It's actually super straightforward. It's just a little bit of multiplication. If you want to go from degrees to radians, you multiply by pi over 180. If you want to go the other way, from radians back to degrees, you just flip it. Multiply by 180 over pi. Oh, and here's a little pro tip for you. If you ever just see an angle without a unit, like just the number 2, you can safely assume it's in radians. That's the convention. Let's do a really quick and easy one together. Let's convert 180 degrees to radians. So you start with what you know, which is 180 degrees. Then you multiply it by our conversion factor, pi over 180. And then you just do a little cleanup, cancel the units, and simplify.
And here's what that looks like. We've got 180 degrees times pi over 180 degrees. Now watch the magic. The degree symbol on the top cancels out the degree symbol on the bottom. The number 180 on the top cancels out the 180 on the bottom. And what are we left with? Just pi. So yeah, 180 degrees is exactly pi radians. It's that clean.
And you guessed it, this whole process works just as beautifully in reverse. If you had pi radians and you multiplied by 180 over pi, the pi's would cancel out and you'd be left with 180 degrees. It's a perfect, logical, and really elegant system.
So there you have it. The radian isn't some scary, complicated thing they teach in advanced math to confuse you. It's actually the simplest, most fundamental way to talk about circles. Which leaves us with one final thought. Now that you understand the circle's own native language, where do you think this might be more powerful than the clunky old system of degrees? And the answer, as you'll find if you dive into physics or calculus, is almost everywhere.